speed of an actuator depends on the flow rate of fluid available to the actuator. The distance moved by the piston inside a cylinder depends on the volume of fluid required to fill the cylinder. Hence, the rate at which fluid fills the cylinder determines the rate of travel of the piston. The given system illustrates the relationship between the speed of an actuator and the flow rate. In this system, the piston moves a distance of 2 feet when 1 gallon of fluid fills the cylinder. The pump delivery is 1 GPM, and the piston covers a distance of 2 feet in 1 minute. Hence, the rate at which the piston moves is 2 feet per minute, or 24 inches per minute. In this case, the stroke of the piston remains 2 feet, but the flow rate of the fluid is doubled to 2 GPM. Thus, the piston covers the distance of 2 feet in half a minute at a speed of 4 feet per minute, or 48 inches per minute. The speed of the actuator is doubled by doubling the flow rate into it. The speed of an actuator also depends on the area of the cylinder. The volume of fluid required to fill a cylinder with a small area is less. For a given flow rate, fluid fills up a cylinder with a small area at a faster rate compared to a cylinder with a large area. In this example, the cylinder area is 10 square inches. The piston moves a distance of 2 feet in 1 minute, when 240 cubic inches of fluid fills the cylinder. Hence, the speed of the cylinder is 2 feet per minute. When the cylinder is replaced by a cylinder of 20 square inches area, the piston moves a distance of 1 foot in 1 minute. This happens because 240 cubic inches of fluid fills 1 foot of the cylinder. The speed of the actuator is reduced to 1 foot per minute in this case. Thus, the speed of an actuator is reduced to half by doubling the cylinder area. The relationship between speed of an actuator, flow rate, and cylinder area can be understood by using the triangle shown in the figure. When actuator speed is unknown, it is calculated as flow rate divided by cylinder area. When cylinder area is not known, it is calculated as flow rate divided by actuator speed. When flow rate is not known, it is calculated as actuator speed times cylinder area. The rod area and the rod end volume affect the speed of a cylinder piston during retraction. In this example, the piston area is 20 square inches, and the rod area is 5 square inches. When the piston extends, it covers a distance of 1 foot in 1 minute as 240 cubic inches of fluid fills the cylinder in 1 minute. The speed of the piston in this case is 1 foot per minute. When the piston retracts, it covers a distance of 1 foot in 45 seconds as the effective volume at the rod end is reduced. Thus, the piston speed increases during retraction due to the reduced volume at the rod end. Calculate the flow provided by the pump in this system. The cylinder area is 20 square inches, and the piston speed is 3 feet per minute.